In this problem, we're given a series that depends on the variable x right there, this variable x right there. And our goal is to find all values of x, all positive values of x, that make this series converge. And our answer is going to be an interval. Right, so these types of problems come down to two things, two basic steps. The first step is to transform an into the form c times r to the n. And step 2, use facts about the convergence, really convergence or divergence, of geometric series. It's a series of the form c times r to the n. All right, so what this means, so if we were to write this in general, right, if we were just write a general series, right, we would write something like an. An is the rule, and then this capital sigma means add them all up. Add them up starting at n equals 1, and keep adding until we get to infinity. Well, keep adding forever, right? We're never going to get to infinity. So, and so if this is, if these are, so if you're putting these equal, you see that you know, the an in this problem is this right here. So step 1 is to turn an into the form c times r to the n. So if you don't understand what I just said, no big deal. Just remember that an is the rule that we put 1 into, and then add that to the rule with 2 in it, and then we add that to the rule with 3 in it, and we just do that forever. This is an, that's the rule. All right, so let me do step 1. So we're going to get it in this form, c times r to the n. And notice that's this form right here, the geometric series. This is the geometric series. The whole thing here. This is the geometric series. The general form of the geometric series. R is called the ratio. C is a constant. C is just a number. Okay, so excuse me, 5 to the negative n times x to the n. Let's see, the negative n, that says bring it downstairs. So we have, so I'll show all the steps. This is 5 to the n times x to the n. This is x to the n over 5 to the n, which is equal to, now think of rules of exponents. This is x over 5 to the n. Okay, so that's our first step there. Let me just write this up here. This is equal to x over 5 to the n. So now, step 2, we're going to use facts about the convergence or divergence of the geometric series. So what are those facts? So the geometric series converges when r, the ratio, is between -1 and 1, not including -1, not including 1. So let me write it like this. Okay, let me write it like this. If R is between -1 and 1, converges. If R is not, if we don't have this relationship for R right here, then it diverges. All right, so how do we use these facts to solve the problem? All right, so the first step is just algebra, and it's just to transform this thing into this form, something to the power n. This one, there is no constant c, so we're not going to worry about that. Okay, so now remember the general geometric series looks like this: r to the n. R, we don't have a constant c, so we just have r to the n. And so for the general geometric series, or for our geometric series, r is equal to x over 5. Let's see, there's another way we can see this here. Using my work that I've done right here, right in blue here, we can rewrite this problem this series we're given. We can rewrite this as x over 5 to the n. And then you see that r is x over 5. Okay, r equals x over 5. We found that. And remember, the geometric series converges when r, so converge when -1, when r is between -1 and 1, not including -1, not including 1. Well, let's see, r is equal to x over 5. So we can put that in. And now we'll solve for x. I'll multiply both sides by 5, remembering that we only have to flip the sign when we multiply or divide by a negative number. 5 is not negative, so multiplying everything by 5. Let's see, I'll put that in, say 5 times that, 5 times that, 5 times that, right? Then let's see, those would cancel there, and we'd be left with -5 is less than x, which is less than 5. So what we found here is that this thing converges for x in the interval -5, 5. And so your answer would be that. That's your answer.